All right. Hello, everyone. Today we're talking about the characteristics of linear functions. The characteristics of linear functions. Go ahead and write this down, the title down, and let's begin. So here's some vocabulary terms we're going to talk about today. So the key characteristics of linear functions include domain, range, intercepts, intervals where a function is increasing or decreasing, positive or negative, maximums, minimums, and behavior. So we're going to talk about all these in more detail today. But first, let's talk about your domain. So the domain is a set of all possible blank values. Okay, so in that blank, we would put, and let me go ahead and fix this over here. The domain is a set of all possible input values. Okay? The domain is our input. When we're looking at domain, we're looking at our x values. Okay, so that's our domain. The range is a set of all possible output values. Okay? Now, this lesson, and go ahead and write that down. I guess pause it, write that down. Okay? And then I'm going to clear that real quick because I want to show you something as you're looking at domain and range. When we're looking at domain, we're looking at the x values. So this right here that's shaded from left to right, that tells us the domain. Okay? And the way, in this case, the way we would identify your domain, it starts, what's the x value it starts at? It starts at 1. And then this one keeps going until 4.1. So our domain goes from 1 is less than or equal to, because it includes that. There's a solid dot here. It's less than or equal to x is less than 4.1. There's an open dot here. So that's why we don't include it, because there's an open dot. It's not included. So we just say less than. This is using in set notation. Okay? And that's how we would write this. And that's your domain. All right. So again, here's another inequality. So when we're talking about domain, we want to move this over. So this starts at negative 1.5. I'm looking at my x value. So I would say negative 1.5. And then I would change this inequality less than or equal to. So open up my keyboard and say less than or equal to x, and then this goes all the way to 1. So I'd say 1 here. And you see that shares your domain. You're looking at the x values. Where does it start? Where does it end? Okay. Now, when we're looking at the range, we're looking at it from the bottom to the top. Okay, so negative 1 on my y value, and it ends at 2. Okay, so we would say negative 1 is less than y, less than or equal to y, because it includes 1, is less than 2. So again, if I was to drag this, when you're looking at the range, you're looking at it from the bottom to the top. Okay, negative 5 all the way to 3. Okay. Again, this is starting at negative 6 all the way to 5. So the range of this function is from negative, is that a 5 or a 6? Oh, that's a 5. Negative 5. Oh, and it keeps going. Oh, I got to keep dragging it till it ends. 5, 6, 7. Negative 5 to 7 is our range. And our domain, though, would go from left to right. Okay. So our domain would start at negative 5. Oh, wait, our domains are x values. So our domain is negative 2, which is where it starts, and then it stops at 6, and it doesn't include it. So negative x Ooh, hold on. Range is the y value, so it's -5 is less than y is less than 7. That's the range. And then the domain is -2 is less than x is less than 6. Okay? So make sure you pay attention to your variables. And that's essentially what we're doing when we're talking about domain and range. So let's go back to our word problem here. So again, your domain is a set of all possible input values. Your range is a set of all possible output values. When we're looking at the graph, for the domain, we're looking at it from the left to the right. Now, with this one, notice that there's an arrow at the end of this. So your domain is actually going to be in set notation. Hold on. In set notation, your domain is going to be x such that x belongs to all real numbers. In interval notation, we would say -infinity, infinity. There's no beginning or end in this for a linear function. Your range is the same thing, y, such that y belongs to all real numbers. Because there are arrows at the end of this, it's not dots. Or, again, -infinity to infinity. That's our domain. Any linear function that does not have like a dot or circle at the end that has arrows is all real numbers. That's our domain and range, unless they put parameters on it. All right. Let's go to the next slide. When there are no restrictions on the linear function, the domain and range will be the set of all real numbers. So that's what I just said. Oops. That's what I just said. There you go. All right, intercepts. The y-intercept, or the starting value, is the point where the graph crosses the y-axis. That's why it's called the y-intercept. The x-intercept is the point where the graph crosses the x-axis. It has an ordered pair of x, 0, meaning it is the x value for when y is equal to 0. With the y-intercept has an ordered pair of 0, y, meaning it's the y value for when x is equal to 0. So that is our x-intercept and our y-intercept. Let's clear all that and move on to our next slide. So a fighter jet descends from an altitude of 800 feet at a rate of 80 feet per minute. The graph of this situation is shown below. What is the y-intercept of the function? What does it represent in terms of the problem? What is the x-intercept of the function? What does it represent in terms of the problem? So let's go ahead and take a look at this. So the y-intercept is where it crosses the y-axis, and that's 0, 8. Our y-intercept is the altitude in hundreds of feet. So the y-intercept of this is 800 feet. That's what the y-intercept is. 800 feet is not just 8. That's 8 in hundreds of feet. So the y-intercept is 800 feet. What does it represent in terms of this problem? It is the starting altitude of the fighter jet before it starts to descend, right? Before it starts to descend. Okay, what does the x represent in terms of this function? And again, use your axes to help you understand it. All right, so that's our time in minutes. So the x-intercept is going to be 10, 0. So the height is 0, and that's time in minutes. So what does it represent in terms of this problem? It takes 10 minutes to land. We hope it's landing and not crashing, right? So this is how we use the x-intercept and the y-intercept in the problem. And just for the fun of it, to make sure you guys understand domain and range, let's see. My domain would be my x value. So this is where it starts, this is where it ends. In interval notation, it would start at 0, 10. I would use brackets because it includes that. In set notation, x such that 0 is less than or equal to x is less than or equal to 10. Okay. Probably should have used red. The color coding part of me wants to use red since I used red to talk about the x-intercept. I'm going to use red to talk about the domain. So again, a domain is 0 to 10 because it starts at 0 and it goes to 10. And again, x such that x belongs to, nope, not real numbers. Forgot already. The lowest number is 0, is less than or equal to x is less than or equal to 10. And that's our domain. Our range, all right, our range is the y values from 0 to 800. And it includes it, so I would say 0 to 800, because remember that 8 is in hundreds of feet. And so I would say y such that 0 is less than or equal to y is less than or equal to 800. And close that up. Okay, so that's the x-intercept and the y-intercept.